Hello, today's video is a guide for performing root cause analysis. The first step in root cause analysis is to clarify what the actual problem is. So defining the situation of a nonconformist requires parts analysis. The first part is to define precisely what the nonconformance is. The second part is to determine the criteria involved in producing a solution. Careful definition of these two parts is essential before proceeding. Without a proper definition, the focus, direction used to determine the solution can be wrong, and this can result in solutions that solve nobody's problem. A problem should have three criteria. There should be a subject, there should be an action related to the subject, and the subject and the action should have resulted in something. Otherwise, it's just an imaginary problem. One way of defining the environment is to define the process. And the tool we use to define the process is flowcharting. Flowcharting was standardized by national and international efforts in the 1960s. The effort in the United States resulted in a set of systems adopted by the American National Standards Institute. It's important to note that the normal logical flow is downward and by columns from left to right. Let me repeat that. The normal logic flow is downward and by column from left to right. I notice people just seem to slap these flowcharts right in the middle of a page. So let's take a look at some of these symbols. There's a terminal symbol. Every flowchart begins and ends with a terminal symbol. It starts and it stops. There's a process symbol. It represents a task performed in the process. There's a decision symbol, and that's used for operations that determine which of two or more alternatives will be followed. It is important to note that in the terminal symbol there's only one out. In the process symbol there's one in and one out. There's not multiple lines. And in the decision symbol there's one in and two outs. Another symbol that I don't see being used on flowcharts, and you should use a lot, is the on-page connector. I shouldn't see lines going all over a page. The next one is the off-page connector, because some flowcharts take multiple pages, maybe up to 30 pages. We should use a document symbol, and that's used to describe an input or an output that is in paper form. There are three basic flowcharts. Three basic flows have been identified in processes. There's a sequential flow, a loop flow, and an if-then-else flow. A sequential flow is those that have the terminal signal start, and we go to process 100, process 101, process 102, and we stop. So that's called sequential flow. The next is what's called loop. And here we have the terminal signal, process 100, a decision at 101. If it's false, it goes up and feeds back. Up and feeds back. It does not feed forward. Anything that feeds forward is out of control. So you notice if it's true, we go to process 102 and then a terminal symbol stop. So we have sequential flow, and then we have the if then else. We start, we do process 100, we make a decision. If this, then this. If not, then this. So if I do an inspection, if the product passed, then it goes to 103, and if the product did not pass, then it goes to 102, and notice we use the on-page connector symbol, so we go in flows down and to the right. So we use these to describe our current process or lack thereof. Another flowchart that can be used is what's called an H.I.P.O, otherwise known as a hierarchical input process output chart. This was developed by IBM back in 1965, and what I've done is flowcharted the ISO 9001-2008 standard here. And so you notice we have an input column, a process column, and an output column. So the input is from the customer, and we could get parts from a supplier. So we go to sales, possibly engineering, production scheduling. We got the purchasing process. We send out a PO. The supplier provides us parts that go into raw material inventory. Those are drawn to work in process inventory. Once work is complete, it goes to finished goods inventory and goes out to the customer. There's two other processes, and this is how we organize and plan the business. And this next one is how to do continuous improvement. So now we have an overall view of the entire system. Another tool that's used that was developed by Ishikawa back in the 1970s is called a Fishbone Diagramming. And here's a simple fishbone diagram, and you'll notice it has method, material, machine, and people. So the method, this is a branch where you would describe those factors of the process that would affect the outcome. So what would occur in the method that would cause the problem, a relationship? Machine, that's right up here. Here you identify those factors which are related to the equipment used in the process. Oh, I see I have a typo here, so don't everybody giggle. We have material. Here you would identify those factors related to the material used in the process. And then here we have people. You would identify those factors related to people working on the process. So these are factors. So gauges are a factor under method. Brittle material under material. Maintenance wasn't performed on a machine. And there was a lack of training of the people. Another method of doing root cause analysis is ranked order analysis. And we go out, we collect information on the nonconformances. And here you can see we have a description of nonconformances. We have cracked, loosened, leaking, sticking, and fractured. And we count how many parts have each one of these deficiencies. We sum up the tally. And then we divide the frequency by the sum to get the percent. And so 33%, or 0.33, of all the problems are due to cracked. Another thing we could do is we could gather numerical data to see how the part or the process is moving, and we can look for the center, the target, or we can look at the actual spread of the data. A typical tool we use for that are control charts. There are 8 different control charts, and of course any point outside the control limits would be a problem. A run of 7 parts above and below the center line would be a problem, and any non-random patterns. All of these shouldn't repeat. They should all be random. They're simply the noise of the process. Here's another example where this is based on attribute or go-no-go information. You can see we have a problem here. We have the control limits. And so we could use control charts to track a process over time. Once we've identified the problem and the cause of the problem, now we can go and start implementing the solution. And what you see here is a Gantt chart, Once the appropriate solution has been determined, a timeline should be established for its implementation. So Mr. Gantt put this together, and Mr. Pert expanded on this. But a simple Gantt chart, and if you notice, training people, system testing, changeover plan and review, what date we started, when it should stop, and that's our timeline. After the solution has been implemented, the process should be measured to determine if it actually removed the nonconformance. So where you can go to get additional information is you could go to Quality Management Theory and Application or Quality Engineer, and those should take care of it. I hope you found this informative, and I'll see you later. Bye.